In this video, I'll describe what inferential statistics is all about. You might have seen the headlines that sitting for too long can be dangerous for your health. Suppose you want to see how widespread this problem might be, so you decide to investigate how far people typically walk each day. Ideally, we'd look at everybody in the entire population and count the number of steps they each took each day, and then take an average. But doing that would require more time and resources than any of us have. So instead of surveying the entire population, you'd look at a sample. Then you'd ask each person in the sample to each wear a pedometer, a device that counts their steps, for a week. At the end of the week, you record the total number of steps each person took, compute the daily average, and find that, on average, the volunteers took, let's say, 8,127 steps per day. What can you conclude? Does that mean that for the entire population, people take on average 8,127 steps per day? What if you had randomly selected a different group of 10 volunteers, and you gave them pedometers, had them wear them for a week, and recorded all of the data and computed a daily average? Would they also take an average of exactly 8,127 steps per day? That would be surprising. You'd expect to get another average that is similar, but maybe a little larger or a little smaller than you did from the first set of 10 people. And all of these averages would probably be different than what you'd get if you could collect data directly from everybody in the population. This phenomenon is called sampling variation, or sometimes sampling error, which is the tendency for different samples from the same population to produce different statistics. In this example, our first sample had an average of 8,127 steps per day, and our second sample had an average of 7,932 steps per day. And one of the main goals of statistics is to quantify the amount of sampling variation. That is, to know how much variation there is from one sample average to another. So how do we go about doing this? Ideally, we'd look at everybody in the entire population, give them all pedometers, and count the number of steps they each took in a week, and see how much variation there was from person to person. But we don't have access to the entire population. So, instead, we start by making a model for the population. A model is a simplified quantitative or behavioral description of what we think the population looks like. For example, we might make a guess, informed by data, about the percent of the population that takes a certain number of steps each day. Then we'd use a computer to simulate randomly selecting 10 people from this population. And then we'd compute the average for this simulated sample. Then we'd repeat this many times, each time simulating the step counts of another group of 10 people. This list of simulated averages gives us information about the amount of variation there might be from sample to sample. And when we have data from an actual sample, knowing the amount of sampling variation lets us make an inference about the population with a specific amount of uncertainty. So, what is inferential statistics all about? The details will change and depend on the specific scenario, but in short, a central goal of statistics is to make an inference about a population average based on the average in a sample. And we do this by estimating the amount of sampling variation by simulating taking many samples from the population.